This g prime, which is like that derivative which involves chain rule. Good deal. And then the other one, Cal, is 33, which is something, I'll be honest, I haven't really covered it. So blame it on me.
Yeah, that.
So I'll put it down over here. When I haven't done something like this, these are not often, they don't come up often. They come up very rarely. Cal, you have this problem, you can tell me. I can check back with you after you finish Comp 3, or maybe DiffEq, you know, DE, differential equation. I can check with her to see how many times something like this came up. Probably not too often. What exponential function do we see all the time? E to the x. And what's that derivative?
E to the power x.
That's the exponential function we see all the time. All the time. See e to the x, e to the x. Sometimes e to 2x, e to 3x, e to 4x squared, all, etc. And out of nowhere, when they come up with something, maybe like, I'm just going to put this down as an example before we do that one, Kelly. 2 to the x. Ooh, e is 2.718281828184590. It's an irrational number. 2 to the x. Define this derivative. It's like e to the x. Will you just write it again? But you also have to put the constant natural log of 2 and multiply to it. Don't get too concerned with these. Not like you see these every day, do you? You don't see 2 to the x's and 3 to the x's and 4 to the x's. But how would you differentiate them? That's how you do it. So you see this? It's like the whole idea is this, Kelly. I have to say I rewrite that exponential function and I multiply the natural log of that base value. Whatever the base is. If that was a 3 to the I'll put ln of 3. That's a constant, by the way. It's an irrational number. Cool. So, what's the most complicated case for these rare cases is where you have any base, right, raised to some exponent different from e to the x, right? Well, then the derivative will be this. Make sure you write the natural log of that base. Do that. Rewrite the base to the exponent. Okay? Kind of like this. But if this exponent here, everyone, is something a little bit more complicated than x, like 2x squared or 5x or 3x, then we're going to have to apply chain rule and multiply the derivative of that exponent. Does that make sense? So if needed, derivative of whatever that exponent is. So before I do this, how about this guy? 2 to the 4x. I'm going to find that derivative. First of all, natural log of what number? 2. I want to rewrite this. 2 to the 4x. Now, before you leave that as your answer, tell you what's the derivative of 4x. See right there, that's the f prime of g. And now all we have to do, that's your little g there. Well, what's the derivative of 4x? Just you know what's in it? It's ln of 2 times 2 to the 4x times a 4. If you want to put the 4l and 2 in front, you can. What would that? You may know a way to simplify that if you wanted to. 4 natural log. Can I move that up here? Yeah, you can write that as natural log 16 if you want. 2 to the 4. Put 4l and 2 is fine. I'll leave it like that. Oh, keep in mind, Cody, we got a lot of these. No, I seriously want to know at the end of this course, or the end of Calc 2, how many of these you see? They rarely come up. Usually the exponential function is e to the x. By the way, it works in the same way. You should see that. It works the same way. Watch this. Get the derivative e to the 4x. Okay? First of all, natural log of what's the base? E. Rewrite e to the 4x. Now, what's the derivative of 4x?
4.
That's the answer. Now, we've done a bunch of these already. Because what's the natural log of e, Kel?
1.
See? See, and this similar? But we do so many of these, ln of e is always 1. It's just this, oh, you gotta write natural log of 2. All the time. Tons and tons of these. Those are rare.
Will you include this in the test?
But doesn't the natural log of e cancel out?
That's right, because natural log of e is just a what?
1.
A 1. So what's the best way to write this answer?
E to the 4. Oh, 4 to the e. 4
You said it.
to the
You
4x.
said it. I love it. 4e to the
4x.
4x. And so what's e to a 5x become?
5.
5e to 5x. See, those are what you're going to see all the time.
So then that wouldn't be the answer, right?
That's right.
Okay.
Now let's do Kel that actual problem in the book. Let's do it. She goes, now I want to see this problem. And it's from the textbook. It's from 3.4 is on page 205. Y equals 2 to the sine pi of x. First of all, natural log of what number?
2.
Check. Second, would you just rewrite that whole expression?
Yep.
2 to the?
Sine pi of x.
Now here comes the chain. There's your g. What's the derivative of sine of pi x? It's just like that one earlier, right? Sine of pi x. If that's your g, what's g prime?
Cosine pi x.
Cosine of a pi x, chain, times up.
X.
Want to agree? Oh, good. I'll just put it in here, right here. Here it is. Pi cosine pi x. No, I'm being honest with you, don't see many of those. I mean, it's great. Here's the new lesson on chain rule. So the author really wanted to throw everything at you. 2 to the x's and stuff, you know, and every trig function, cosine, sines. That'd be the answer.
Will I see one student say next Tuesday?
Probably not. You know why? Go through that book. See how many more you got of those. That's the idea. So if you had like 10 more to practice of these, oh yeah, put it on there. If this is something like, oh gosh, this comes up in Calc 2 and Calc 3 all the time. Or DE, I have these every day. Well, heck, I'm going to have it on there, right? But seriously, the kinds of things I'm seeing all the time are these functions. And these functions. Which Amber, you've seen her crush, right? Sure. The derivatives. 5e to the 5x, right?
Yeah.
And 4e to the 4x. Hey, before you get hooked on that, you see a lot of these too. Anybody know what rule you got to use here?
Product.
Good. Product. It wasn't a 4 in front. You need product rule there. First time derivative, second time derivative, good. Just to recognize that, that's outstanding. Things like that, product rule, or this guy. Product rule. Right? 2x cosine. Product rule. Product rule, all of them.
What about if you're in like 400 level, like when you do advanced calc and all, it doesn't come?
Nope. But it's like once in a blue moon you get this 3, and you go, oh, how you go, oh yeah, natural log of the base, natural log of 2, or natural log of 3, rewrite, and then you do the derivative of it. Cool. All right, these are important. What about our SCSES? Differentiate that way, right? For sines and cosines, those come up a lot. But yesterday, we added some inverse trig functions. So can I put them down?
Yeah.
And if you don't mind, I'm going to write them in terms of u. What if y equals arc sine of u? Then I could say the derivative will be whatever u prime is over square root of 1 minus
U squared.
u squared. How about inverse cosine? U.
Same thing but with a minus.
How
Negative.
about we write negative sine? Does that work?
Yep.
Negative sine. Just like arc sine. Same thing, but negative.
Can we do that on the test?
Yeah. If you already wrote the arc sine. Because that'd be the same as what? Right? You have to like draw an arrow. Ah. I'll be honest, through Calc 2 and Calc 3, this is the inverse trig function you will see the most, this guy.
Cotangent, no, so tan.
Inverse tangent. He doesn't have a radical. Oh, I want to write in terms of u, right? So the derivative will be 1 over 1 plus u squared times the derivative. So here, just so you can follow that example, what's this derivative? Inverse tan of x, which is also written as arc tan of x. What's that derivative? If it was just an x.
1 over x squared.
So if x 1,
Well, 1 plus x squared, sorry.
I mean, that's one you go, I want to make sure I'm familiar with that. Arc sine too, yeah, arc so cosine. Those are the three I need you to know, Belraj. Right? Those three. But you can look at your textbook. Aren't there 3 other trig functions?
Yeah, cosecant, secant.
Might as well put them down, right? You're taking notes, everyone. You know it's in the book, but a lot of you refer back to your notes when you go into Calc 2, and you might want to find this. And you go, well, what page are they on? You'll see them on page 214. Okay? Cool? But I said, Cal one of these.
No,
My guess, right?
say in case if it was like cosecant inverse of u. So it will be like what? 1 over u prime? Like that?
Got it.
Okay.
I love it. Hey, watch this. Might as well add this to the list. Don't write it, don't like this. What's this one? Same as that, but
Negative.
let me just draw an arrow. You want to see that? Oh, inverse cotangent. Same as inverse tangent, but just what? Now, which ones you don't see too often? But we need them in your notes because, well, they don't come up too often. Every once in a while in a Calc course, get them. Calc 2 course, too. And you'd want to know them. You want to impress your Calc 2 for that one. Who's missing? What 2 trig functions? Secant? Cosecant? So I'm going to write inverse secant and inverse cosecant. So add them. Here they come. Did you see these often though? Well, this looks like this guy,
It's just flip.
basically. Rather than writing 1 minus u squared, does everyone see what I wrote? But there's one other thing. In this denominator, right here, there's another little u. And when you can see this, you'll see this written on page 214. And when that started with a C, that started with a C,
So negative.
and it was negative that. This started with a C, it was negative that. This inverse trig function starts with a C,
Negative.
it's negative something on the board. Which one is it?
Sine.
Negative of that. But these two you will not see what? Often. Which ones will you see a lot of? This one and this one. See a lot of those. I'd say inverse cosine too. But I still don't see them as often as those. So hey, again, since it comes up so often, what is that derivative?
1 over 1 plus x squared.
You go, why is that so important? Why is Professor Rushing saying that's so important?
That's the tangent line.
Yeah. And everyone, in about 3 weeks, we'll be doing something called antiderivatives. And the symbol, you go backwards. You go this way. And the symbol you use is the integral symbol. And out of the blue, you're going to get this problem in the book. And you're going to look at it and go, "Man, I can't remember doing one like this in class." And you'll be like, what technique am I going to use that looks confusing to you? And they're trying to see if you recognize, oh, antiderivative, this will just pull it right back to what?
Tan inverse x.
That right there. So you don't have to write that down. That's a future topic. That's an integral symbol. That means you're going to find the antiderivative expression. And since derivative constants is always 0, we just put plus constant there too. Cool. So that's what I mean. That's why that one's pretty darn important. Hey, let's try one know everyone about where we need chain rule. So, good luck. Now you'll get it. Ellen, can you find the derivative of inverse sine of 9x?
Yep.
Could you find that?
Yep.
You're sitting there and you're like, oh, that's the one with the square root. It's not negative, it's positive, right?
So it should be 9 over 1 plus 9x squared.
And watch, I'm going to make an error. This is what I see on a test. Students remember to put the derivative of this here. Do you remember the 1 minus? And they remember the square. Wah, wah. I see stuff like that.
Oh, 81, sorry.
Right? But no, not you, Art. You got it right. That was right. This is what I see. I see that. Or sometimes I see 1 minus x squared. What's wrong with this? This, yeah, you got it. It's this.
That's good.
No, you got to square that whole thing. Now, if you put the parentheses there, that's good. But I think you all know how to square a 9 and an x same time. What do you get?
81.
81x squared. Happy face. There you go. That's it, though. Leave it. Oh, no, you can't factor. I can factor that. It's a difference in square, but you can't factor anything out of it. You got a square root of 1 plus 9x and a square root of 1 minus 9x.